Hi, grade 12. There we go again. So, I'm so excited that we are doing physical science. I wish you guys can see my excitement. But as we move, I'm going to improve. I'll have my camera on so that you guys can see my excitement on physics. There we go. It's a ding ding ding. So, it's a ding 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 means it's time to learn. So let's dive into it. This is Physical Science, Paper 1, May or June, Sub-Exam 2025. This is out of 150 and you're going to write this paper for 3 hours. So please make sure that when you get in an exam, you read the question, and then the only one that I'm gonna go through now is this one, 2 decimal place. Right, so let's start with the multiple choice question. Guys, I like physical science. This is one of my favorite subjects. So hopefully on our next past paper, we'll do the 2017 one, the one that I wrote in Matric. So this is a multiple choice question you are failed to, and if you can look at this. Okay, let me tell you about me on the multiple choice question. I used to get 20, all the marks. I used to collect all these 2 marks. You know why? Because nginenkani. Guys, now, like, I won't allow to get a question wrong while I have the answer on the paper. The answer is there. I just have to find the correct one. I'll never get that one wrong. Let me teach you how to answer a multiple choice question. Let's start with the first one. They said that we have 3 vectors. 3 vectors act on an object so that the resultant force is 0. The resultant force is 0. So what I need you to understand is that for 3 forces to have a resultant force of 0, guys, we're going to take this step by step, and I'll try to move slow, because now I can feel that I'm overexcited and already I'm moving fast. So let me try to slow down. So the resultant force, for 3 forces to have a resultant force of 0, right, they must form a closed vector triangle. So these guys, they must form what we call a closed vector triangle. I know that someone watching the lesson now is saying that Sir is trying to say head to tail. Yes, you are right. That's what I'm referring to. A resultant force is 0. The 3 forces, they must create what? A closed vector triangle using a head to tail, not tail to head, but head to tail. Right. So now, another thing that I need you guys to understand, this means that number 1, when we say how do we form a closed vector triangle? Each arrow must start where the previous one ends. So each arrow must start where the previous one ends. I'm not going to write that down because we're going to waste time. Or maybe, you see now, each arrow must start where the previous one ends. Very important. So now, the last vector must bring you back to the starting point. Okay, that's number 1. That's point 1. Point 2, then we say the last vector must do what? Must bring you to the starting point. Starting point. Right, so let's start and check these vectors, because to create a closed vector, we say 1, each arrow must What is this? Each arrow must start where previous one ends. So I'm going to choose, they say which one of the following represent, they said which one of the following vector diagram is the correct representation of the three forces. Remember that I'm saying to get a resultant force of 0, we need to create a closed vector triangle. What is a closed vector triangle? We know that each arrow must start where the previous one ended. Let me say this one starts here, then it moves up, then look at this arrow. So now, as you can see where the arrow of that one is, it is meeting with another arrow. So can you see that the arrow of this one doesn't start where the arrow of that one ended? So option A is out. We move to option B. Option B, this one starts here, then it goes up, this is where it ends, then this arrow starts here where that one ended. Yes, that's what we are looking for. We move that, then this is where that arrow ends. But look at this, 2 arrows pointing on the same one, so option B is out. Remember, each arrow must start where the previous one ended. Right, because if I have an arrow like this is my starting point and this is my ending. So each and every arrow must start where the previous one ends. Let's go to C. Look at C. C starts here, then it moves up to that point, then look at this. This one is head to head, it's out. It's not head to tail, it's out. So this leaves us with D. So this tells us that D is the correct answer, but let's quickly verify that. So this one, it starts here, which is my starting point, then it ends here. And then the second arrow, it starts here, starting point, and this is my ending point. And this is what I need. Get in. It's a ding ding ding. So now when I go to this one, what is this? This one is my starting point for that arrow, and this is my ending. Therefore, the correct answer is D. That's how we answer that question. I hope you guys are happy about that. So this tells you that A, B, and C, they don't form a closed loop. Some vectors are not connected head to tail properly, so they are out. Let's move to the next one, 1.2. Two large objects P and, they say two large objects P and R, each of mass M, we can see that on the diagram, are placed with their centers R apart, as shown in the diagram below. They expect a gravitational force of magnitude F on each other, and then now the mass of R is increased to what? To 2m. So the mass of this one now is 2m. It is increased, and the objects are now placed so that the distance between their center, the distance is doubled. Guys, if you watched my previous lesson on electrostatic force, you know how to answer this question. Right. So we said that on that lesson. Remember that the force, the electrostatic force, is directly proportional to what? To the charges, and inversely proportional to the distance between them. So now I'm going to write this. I said that if they want you to use the charges and the distance, we're going to say F is directly proportional to the charges, which is Q1 and Q2, and F is inversely proportional to the distance. So now let's substitute. I'm going to name this as my Q1, then this will be my Q2. So Q1 is just M, so I'll just substitute M. So this is F. Okay, let's write this down. F directly proportional to Q1 Q2 over R squared. I'm already having much fun now. We're already on multiple choice and I'm enjoying the lesson. So this tells me that you are also having fun on your side. So it's a ding ding ding. Okay, so Q1, what is Q1? Q1 is just m, let's substitute, multiplied by, what is Q2? Q2 is 2m, then this is divided by, in fact, you know what I'm going to do? To make this simple, let me write this in this form. Let's say I have my Q1, which is m, and then I have my Q2, which is 2m. So this tells me that this is just Q, and this will be 2Q2. Let's substitute that. So this will be Q1, it's just Q1, but Q2 is doubled, so this will be multiplied by 2Q2. Divide by what? R, it's 2R. So the value of R, I'm just going to substitute that as 2R, which is squared. So what do we have on top? We have, I'm going to write this as 2 of Q1 times Q2. What I did, I just moved the Q in front. Then this is divided by 2 squared, it's 4. Then I'll have this as R squared. So now I'm going to move the 2 over 4 this side. Multiply that by the Q1, Q2 over R squared. Look at this. I know that this part here, this part here, it's my F. So if that part is my F, now what is 2 over 4 equals to? This is 1 over 2 times, we know that this is F according to the formula. Can you see that? So this will be F. So you're going to check on your multiple choice which one is 1 over 2F is A. It's a ding ding ding. So now that you get this one, everything is good. Né? So that's how you answer a multiple choice question. Let's move to the next question. Right, this has to do with vertical projectile motions. The velocity versus time sketch graph below is for the motion of a ball that is projected vertically upward from the top of the building. So I'll start by making my own drawing. I have a building that has the height h, and this will be my ground. Let me explain what's going on. This is you, the grade 12 learner. You are standing on top of a building, then you project what? A ball vertically upwards. So it will move up, it reach a maximum height, then it comes back down to the ground. But now there's something that we need to note. What happens when the ball hits the ground? It's going to bounce back, but it won't bounce back to that maximum height. No, it will bounce back and reach another new height which is lower than that one. It will keep on bouncing until it stays like at rest, stationary. So guys, let's look at this graph. They say that this is projected from the top of the building and this is my max. I know that at max V it's equal to 0 meters per second. Let's write that well because this is important. The max, at max, the velocity is 0. At max, the velocity is 0 meters per second. So now the question says the ball reached its greatest height above the ground. Which one is the greatest height? Which one is the greatest height? We need to check the greatest one. Is this one? It should be above the building. You see, above the building, this is my greatest height. So now they say at a certain time, which point on the graph corresponds to this greatest height? You need to be like very good when it comes to this, because we know that, okay, the ball will go up the moment that you project something up. Ne? The moment that you project something up, the more it goes up, it reduces in velocity until it reaches what? The maximum of 0. So can you see that it will start here and move down, and then it reaches the maximum of 0. So the velocity here is 0. Why? Because this line here, you see this line where there's arrow, it's our point reference. Our point reference. Right. So at the point reference, the velocity is 0. So now we know that this point Q is our max height. So now they say which point corresponds to this greatest height is just Q. So the correct answer will be B. So now what happens to the ball? The ball, the more it moves up. So this tells you that we take up as positive. So this graph, when they draw, they considered up as positive. So then this part here, it's when it's going up. Then you see this part here. Because now I'm already explaining in case you do calculations. Né? So this part here, it's what? It's negative. So this is positive because the ball is moving up. This is negative because the ball is moving down. And we have up as positive. Why? It reaches 0, then it starts moving back. So I'm going to name this on my graph. This is point P. Okay, let's use a different marker so that you guys can do it. See, now I get too much excited. Now I'm explaining a lot of things on this 1.3 question. But this is going to help you there. So now this is P, point P. It moves up to point Q. Then it will come back to the same, it will pass through that same height and move what? Then it's going to hit the ground with a certain velocity. And when it hits the ground, this will be my point R. Then if that's point R, the ball will start moving up. So this tells you that this part here, we said that this part here is positive and this part here, it will be negative because it's moving downward. Then it will start going up with positive. So this is where it's going to start going up. So what I need you to understand is that this point here and that point here is the ground. And this one is also the ground. Right. So it will hit the ground, reach another max. Why do we say this is max? Because the max will be at what? So this is from this will be S. Why? Because at X the velocity is 0. This tells you that this one is at maximum, then it will come back down. I hope this makes sense. But the most important thing is for you to understand how we got B. We had so much, I think I explained a lot of things for sure. Now you already forgot how we got B. But please just try to go back on the lesson and understand how we got the value of B. Right, and there we go again. This is 1.4. So let's see what we have on 1.4. 1.4 has to do with what? It has to do with inelastic. So now they say, what are they saying? Two hard objects collide inelastically in an isolated system. You see, I underline the most important words. So, in an inelastic collision, right, I'm just going to give you guys this here. Let's say this is inelastic. Right, so this is inelastic collision. And then on the inelastic collision, this is in what? In an isolated system. Isolated system. What do we know is that look at the statement, which one of the following is correct for this collision? Both momentum, look at this guys, remember I'm training you how to master multiple choice question. Both total momentum, I'm going to underline momentum, and kinetic energy are what? Conserved. Both total momentum, kinetic energy conserved. Total momentum, kinetic energy conserved. Total momentum, kinetic energy conserved. You see, we have like same ways appearing each and every. How are we going to know if this is which one is the correct one? Then I know someone is going to close their eyes and say where I land my hand, that's the correct one. They just gamble with these 2 marks. Easy 2 marks. No, we need to collect that. So look at this. First thing first, oh, we're talking about momentum. I know that I'm going to talk momentum. Then you write total momentum down. We know that total momentum. Remember, we are talking about inelastic. So the total momentum is what? The total momentum, this one, it's conserved. So we're going to say the total momentum is conserved. Right? That's what we need to know. The second one, in an elastic, total kinetic. Total kinetic. This one is what? The total kinetic, not conserved. Right, I'm going to use this to answer the following question. So look at this. I'm going to eliminate some of the options. Option A, both total, for the fact that they said both total and kinetic energy are conserved. This one is conserved, this one is not conserved. Look at the statement that I just gave you. In an elastic collision, we said total momentum is conserved, but total kinetic is not conserved. So this one is out. Option A, out. Let's move to the next one. Neither total nor kinetic energy is conserved. We know that the total is conserved, this one is conserved, but the option is saying none of them are conserved. So option B, out. The total momentum is not conserved. So for the fact that they said total momentum is not conserved, while we know that the total momentum is conserved, it's wrong. Option C, out. Then option D, the total momentum is conserved. Yes, I agree with them on that. But the total kinetic energy is not conserved. I agree with them on that. Then this will give me the correct answer as D. It's a ding ding ding. Get in, guys. We are having so much fun. I'm enjoying that. I wish you guys can see my excitement. Let's move to the next question. 1.5. 1.0. Before we move to 1.5, let me give you something, guys, so that you don't maybe get like confused if they try to switch this question, because you might be lucky and they bring it like this again. So let me give you something that you can remember. This is a quick exam tip. Right, so elastic solution collision, because in this multiple choice they asked you about what? They ask you about inelastic. Let me tell you about the elastic collision. So the inelastic collision, momentum plus kinetic, let's call it KE, kinetic energy. When you add these two, they are conserved. So when you add the two, kinetic and momentum, both of them, when you add them, they are conserved. Right. Then in inelastic, so this was for elastic. So inelastic, collision, only momentum, only. So only momentum conserved. I think, guys, when I say plus, it's maybe someone might be confused. So instead of saying plus, let's use and. So momentum and kinetic energy are conserved in an elastic. So in elastic, so in an inelastic, momentum, only momentum is conserved. So in an exam, they might change the statement. Instead of saying inelastic, they say elastic. Please pay attention on that. Get your weapon ready. Wait for them. That if they change this thing, you're going to ding ding ding. Yeah. So let's work on this one. Engine P has a great maximum power output than engine Q. Yo, I really like this type of questions. Né? So they say that engine P has a great power output than engine Q. So remember, power is equal to the work done over time. That's the formula for time, for power. And they say engine P has a greater maximum power than engine Q. That's a statement. Né? Which one of the following statement is correct when P and Q each operate at their maximum power output? Q does more work than P in the same amount of time. P and Q do the same amount of work in the same amount of time. P and Q, look at this. It's all about more work than, same amount than, you see? So now let's try to find the correct statement. So in order for you to find the correct statement, you need to understand this statement that says engine P has a greater maximum output than engine Q. Let's try to analyze that. Okay, so now what they are saying is that if engine P, I'm just going to tell you that if engine P has greater power, because that's what they told us on the statement, than Q. What can we say about that? So this tells you that P is the one that is going to do, okay, B does what? The same work. P will do the same work in less time. That's what you need to understand. Or you can say P does more work in the same time. Or let's say P does more work in the same time. So you just have to do vice versa. Look at this. If it's same time, P is going to do more work. If it's less time, P is going to do the same work. I hope you guys understand that part. So Q does more work than P in the same amount of time. Remember we said P is the one that is more powerful. So here they are saying Q is the one that is doing more work. This one is out. Then P and Q do the same amount of work in the same amount of time. So we have same, that one work, because we said if we have same time, there will be more what? More work. If there is less time, there will be same work. So we have same, that one work, then this one is out because of same amount of time. Same amount of work, same amount of time. That one is out. So P and Q do the same amount of work, but Q does it shorter timer than Q. So remember we said Q, here they're saying that P and Q, they do the same amount of work, but they say Q does it in a shorter amount. So they are trying to say that Q is faster. Q is faster. So if they say Q is faster, this tells us that Q is more powerful. So they are wrong. P is the one that is powerful. This one is out. So this will leave us with the last statement. P and Q does the same work. So they do the same work, but P does it in a shorter time. So the correct one is D. Look at this. P does it in less time. So the correct one is P. So exam tip for this one, you know the best way to do this. Just know that more power, it equals to faster work rate. I can't believe that we're wasting no, we're not wasting so much time on multiple choice. We are learning, right? And that's it for this question. So let's move to the next one. So they say that the absorption of a spectra of the same element surrounding both star A and star B are observed from F. The spectral lines for star B are more red. Okay, so I'm just going to analyze because I see something here. I see something very important. I'm just going to analyze that. B are more redshifted than those of star 8. So when we say something it's more redshifted than another one, this tells you that for B, more shifted, it tells you that its light is shifted toward the red. So its light, the light of B, is shifted towards what? Towards red end. Guys, when it says is shifted towards red end, what is this meaning? This tells you that this has a what? It has a shorter wavelength. Oh, not shorter but long wavelength there. So this will have a long wavelength. Don't worry, everything will make sense now. So this tells you that since we know that C is equals to frequency multiplied by the wave. So if the wave increase, the frequency decrease. Okay, so the wavelength, if the wavelength increase, what happens to the frequency? For example, look at this. I can arrange this and say lambda, which is the wavelength, it's equal to C over F. Can you see that the wavelength is directly proportional to C but inversely proportional to F? So if the wavelength increase, so if this goes up, the frequency will decrease. Right. So what are they saying? They are asking that, okay, but before that, let's conclude on the information that we have. We know that the frequency of B, remember they said that this one is shifted towards the red, and we said it's going to have a long wavelength. So since it has a long wavelength, it's going to have what? A shorter what? A shorter frequency. So the frequency of B, what is the frequency of B? Is lower than of A. That's what we know so far. Right. So that was, we used the shift, the red shift, and then now remember we can also do this with the speed. We are done with the frequency. Now we know that the frequency of B will be lower than A. So now let's talk about the speed. Let's talk about the speed. We are done with this column. We're going to be able to choose which one is the correct. Let's talk about the speed. So the speed, remember, if they tell you that this is more rate shifted, if it's more rate shifted, this tells you that the star is moving away faster. So the star is moving faster. Star is moving faster. I'm just gonna write faster. The star is moving faster. So since the star is moving faster, now we know that they said B is more rate shifted. So this tells us that B, what can we say about B? Has a greater speed. So B has a greater speed. B has a greater speed than A. Guys, I know this is so much information. Try to pause the lesson, go back, uh, collect the information that I'm giving you. So what will be the final answer? We said B is going to have a, a frequency. The frequency of B will be lower than. So on this column, we need for B to have a lower frequency. So I'll just tick the column that has lower. Then we said that B will have what? Will have a greater speed than A. So the speed of B is greater. Then you tick all the columns that has a greater. So now look at this. The column that has 2 ticks is your correct answer. Which one is it? C. Guys, this is how I used to find, this is how I used to get 20 on multiple choice question. But I think it also has to do with understanding the theory beside the topic, the concept. Okay, it's fine. Let's move on the next one. Let's see what we have on this one. 1.7, guys, are we going to spend an hour on this? Come on. It's okay. It's okay, because remember, I'm not just using the memo and tell you that the answer is B and you don't understand why the answer is B. I need to make sure that I explain where is that answer coming from. So I'm afraid this lesson is going to be long. But if you need to collect the marks, sit in on the lesson. Let's finish all this question. Can you see how nice the questions are? Look at how nice the questions are, and I'm going to make sure that by the end of the question, you know how to answer all these questions. Okay, let's go back and work on that question that we are currently doing. Let's go back on that question. Let me see, this was 1.7. They say that R and S are 2 small charge spheres placed distance apart. We can see that, okay, we can see that. And then they say that P is a point to the right of sphere S. We can see that also. And then ER and ES are the electric fields at a point due to the charges on sphere R and S respectively. We can see the diagram. Which one of the following combination is correct for the net charge on the sphere? Okay, so I'm just gonna try to analyze what we are given. They say ER. Okay, let's not analyze what we are given. Let's just go straight to the answer. Let's just go and answer this. So look at this ER. Where is the arrow of ER pointing? To the right. So I'm going to say my ER points to the right. ER, it points right. And then what about ES? ES, it points left. Okay, I can see that. And then now I need you to remember this rule. Remember this rule. When you go to an exam, make sure that you remember the rule. NB. Oh, shucks. NB. NB. You know what, guys? I think I know what we should do on this paper. We're going to create, okay, it's fine. NB, remember the rule. So the rule is that electric field they point away from positive. They point away from positive. Okay, electric field away from positive charge, and electric field they point towards a negative charge. So they point away from positive charge and they point towards. We are coming to that now. So now look at sphere R. I'm just going to try and analyze the sphere R. So let's look at what we have here. Sphere R. Let's go and check on what we have on that guy. So this is my R, which is like this, and then we can see that point P is to the right of R. So this is my R, this is my point P. So can you see that point P is to the right of R? Okay, remember, if this is my R and this is point P, this side is left and this side of R is right. So point P is to the right. I'm going to write this down there. For sphere R, we are saying that point P is to the right of R. I'm very sorry guys, I just have to explain everything there. So we know that the field due to R at P points to the right. So now let's look at this. The field due to what? Due to R. The field due to R, it points what? It points to the R, to the right. I hope you guys can see that. The field due to R, it points to the right. That's what is going on here. So that means the field is pointing away from R. Field is pointing away from R. So since it's pointing away from R, look at this. Away from positive. This tells us that R must be positive. Get in. So now you can see what I'm trying to do here now. This is my R and this is point P. So P is to the right of R, and now look at this. Electric ER is pointing to the right. So if it's pointing to the right, what can we say about sphere R? So sphere R, we say the field is pointing away from R. You see where is R and where is that arrow going? It's away. So since it's away, this tells us that R is positive, because away from positive, the electric field will point away from positive. So without wasting any more time, I think already now you understand that if we analyze this for sphere S, we do the same. We say point P is to the right of S. So, right. So, for sphere S, look at this. Sphere S, where is sphere S? Point P, this is my S, and this is point P. So this side is right, and this side is left. So this point is also to the right of S, of that S. So you can just write it down. It's also to the right. And then where is this pointing? The point of ER is pointing to the left. So the field due to S at P points to the left. So this one, it points to the left. Right, just read the statement. The field is pointing to the left. So since it's pointing to the left, it's going towards what? It's going towards S. Can you see that? Look at the arrow. It's going towards S. So since it's going towards, this tells us that S must be negative. So S is negative. So already you know how to answer this one. You go on your table, you tick the one where R is positive. Let's quickly tick those. Where is A? We need R to be positive. We need R to be positive. So these two guys are out. Right. So since those two are out, we need, okay. So now, we know that sphere S is negative because that one is pointing towards. So towards is negative. We need to tick all the negative ones. Negative, negative. The row with 2 ticks is the correct one. It's a ding ding ding. Now you understand how to answer that one. So I think this one was very important, and for you to analyze the sphere R and sphere S to know where is this pointing. Guys, I'm having so much fun on my site. Now, let's see what we get here. Oh, this is going to take longer. Let's see. They say that the circuit below was used in a practical investigation. The battery has an EMF and the internal resistor R. Ignore the resistance of the connecting the wires. Graph K and L below were obtained from the readings taken. And now they say that okay, we can see the diagram. There's graph K, there's graph L. Which one of the combination below correctly indicate the voltmeter reading taken to obtain graph K and L? Okay, so what I'm going to do on this one, you know what I'm going to do? I'm just gonna first, let's analyze graph K first. This graph K, let's analyze that guy. So K is a straight line. What is this telling you? It's a straight line that passes through an origin with a voltage. You see the voltage, it's increasing as the current increase. So this tells you that the voltage is directly proportional to the current, because the more the voltage increase, the more the current increase. So now what is this telling you? This matches the Ohm's law. Right. This is the Ohm's law. The Ohm's law says V is equals to the current times the resistance. So this is equals to the current times the resistance. So from this Ohm's law, so this graph must be the voltmeter reading across the external S. So it must be the voltmeter reading. So this tells you that graph K, it needs to be the voltmeter reading across the external resistor S. So where is that one? When I look at this tells us that this is where, let's look at this properly. It should be what? The external resistor across S, which is V2. So for this graph, we used V2. I hope you guys understand what is going on here now. Because we can see that the moment the voltage increases, the current also increases. Okay, so now let's analyze graph L. Let's see what is going on graph L. So graph L shows a voltage that is decreasing as the current increases. So the voltage, it decreases and the current increases. So remember, for a cell with EMF, and the internal resistor, the terminal potential difference that we use is V is equals to E minus the current times the internal resistor. So this is the formula that we use. So the current increase, and the terminal of the voltage decreases. If the current increases, this V decreases. So look at this. So this is going to be what the V1 is going to measure. So the V1 is going to measure that. So the V1 is across the battery. So the V1 is across the battery. Just know that if the voltage decreases as the current increases, just know that it will be across the battery. So this makes sense. V1 is for graph L. So this will be for V1 because the voltage decreases as the current increases. So this tells us that graph K is V2 and graph L is V1. So I'm going to give you a quick way to cram this so that you don't forget it. Now, if the voltage increase with an increase in resistor, look at a circuit like that one, because look at this. This is my resistor and this is my voltage. Then if the voltage decrease and the current increase, look for the one that is across the battery, which is that one. So then we know what happens. So you just have to use your graph to check what happens if the voltage increase, what happens to the current. The voltage increase as the current increase. This side, the voltage decrease as the current increase. Then that will be easy for you. Let's tick on the graph. We know that graph K is V2. So I'm just going to analyze, tick the one for V2, V2. And graph L is V1. Tick the one for V1. The one with 2 ticks, it's a ding, ding, ding. So the correct answer for this one is C. Okay, which one of the following is the function of the split ring commutator in an electric motor? So which one is the split ring? So remember the split ring commutator, it has to do with rotating the coil. So for now, I'm going to consider that A because I know that the split ring rotates the coil. So let's keep on reading the one so that we can choose the correct one. They say number B, it delivers current from the coil to the external circuit. No, you only look for the one that rotates the coil. Ensures that the coil rotates continuously in one direction. So we're going to also consider C. Ensures that the current black out, because we are looking for coil rotate. But remember, the split rings function is to make sure that the coil rotates in one direction. So now, option A doesn't have this statement, one direction. Option A is out. This leaves me with C. So the correct answer is C. I hope you guys are happy with that. The correct answer will be C. So now let's work on the last question. They say that which one of the following statements correctly describes the photoelectric effect? An electron absorbs the energy of photon and emits light. So they said that it emits light. Wrong. We know that it absorbs energy. It absorbs. So an electron, it absorbs energy. That's correct. And it do what? It ejected. And it's ejected. So emits light is wrong. They were supposed to say it's ejected. So this was supposed to be ejected. So now an electron emits a photon when it collides with another electron. So this is not the definition of photoelectric effect. This is not the definition, so it's out. An electron absorbs energy. Remember, this is what we ticked on top. And eject. We are looking for that ejected. That's correct, from the surface of the metal. So that's correct. We're going to consider taking C. A photon is emitted when an electron moves from a lower energy level to a higher energy level. A photon, guys, it doesn't, a photon emission, so the emission of a photon, the emission It happens when electrons, they move down, not up, guys. They move down, not up. So the mistake that they made, they say they move from what? From a lower energy to a higher energy. So they are saying that they move up. The correct one was supposed to be down. So that was the statement. So this will make D to be wrong. So the correct answer is C. And that's it for this question, guys. So I'm not sure if you guys were enjoying the lesson, because we take so much time answering this multiple choice question. You know what we're going to do to make this lesson more easy? This is where we're going to stop for the lesson. So we're going to separate the whole lesson, and this lesson will only be for question 1, multiple choice, and our 4-hour lesson will be answering question 2 all the way to, let's see the last question, all the way to question 10. Right. So if you need to watch the next lesson, which is a 4-hour question watching, where we answer this question, make sure that you hit the subscription button if this is your first time watching our lessons. So then you're going to work with us the question 2 going down. For question 1, I think we're just gonna stop the lesson here, because when I check this lesson, it's already 1 hour. The lesson is already 1 hour. So I'm not sure if we should continue with the lesson and make it one lesson, or maybe we should do, it's fine, I'll pause the recording now and decide. So if this lesson is, if you see that this is not the end of the lesson, just know that Ziawa, it's a ding ding ding, time to learn. Okay, ladies and gents, I guess we're going to keep the ball rolling. So we're just gonna continue working on this question all until the end. So let's look at what we have on question 2. They say that a crate of mass 25 kg slide down a rough inclined surface. So now on this question, they said it slides down a rough inclined surface at a constant speed. So the constant speed means that the acceleration of this is 0 meters per second. Very important for you to note that down. Right. I'm sorry. There's a constant speed, and okay, so the acceleration is 0, and we have the velocity. So this is the velocity, 2 meters per second is the velocity. So please don't confuse the velocity with the acceleration. Towards point A. So this box here has to move from that point to point A. And then they say, while the force F acts on it. Can you see where is this force going? The force is pointing up, but the box is still moving. So this tells you that they are not applying enough force to prevent the box from sliding down. They say that this is parallel to the incline as shown below. A constant kinetic friction of the force of 40 newtons. So we are given Fk. The kinetic friction as 40 newtons. And then it acts on the crate when the plane is inclined at an angle of 30 with the horizontal. We can see that. Let's answer the following questions. So the first question says that they want us to state Newton's first law in weights. Please make sure that you consult the exam guideline on how to state Newton's first law. So Newton's first law says that a body will remain in its state and which state are we referring to? The state of rest. The state of rest or motion or motion at a constant velocity, at a constant velocity, right? Unless we have, unless a non-zero resultant force acts on it, unless a non-zero resultant force acts on it. So guys, I need to give you a tip when you work with physics questions. This is how the physics questions work. If they say state Newton's first law, just know that most of the questions that you're going to answer after that will be based on Newton's first law. And remember, Newton's first law is F net, it's equal to 0. But we'll keep on reminding you on that one. Let's start with the 2.2. Draw a label free body diagram showing all the forces that are acting on the crate as it moves towards point A. So we need to indicate all the forces. So if you look at this, we have F going up, and then we know that this is on incline, is going to have the weight that is parallel to the horizontal, and we call that weight Fg parallel. But now these are not the only forces. We also have another force acting up, which is the force of friction. Why? Because the box moves down. So remember, the force of friction always acts in an opposite direction of the motion. Then we're going to have the weight acting down. This is my Fg. Then I'm going to have what? My Fn, my normal force. Right, I'm just going to draw that free body diagram here and say this is my 2.2. So on 2.2, we are saying we have there the Fk going up, which is the kinetic friction, and we have F, which is the applied force, and then we have Fg parallel acting down. Then there's a weight going down there. So I think if I put it like this, it looks like it's not on incline. Let's quickly fix that now. Guys, I'm not on fire yet, but I'm just doing quick warm-up so far. So this is my kinetic friction, and then this will be my guys, I'm very sorry, what is this? Okay, so this will be my force applied, and then the force that is going down is Fg parallel, and then we're going to have the weight going down. This is Fg, then the normal force will be perpendicular to the surface. Okay, I hope when you draw this, I'm just gonna remove my component. Let's avoid also putting the components when you draw. So I'm just gonna leave it like this because this is 4 marks and I should give them 4 forces. Right, the next question, which is 2.3, calculate the magnitude F. They want us to calculate the applied force, so I'm not going to stress much about that. First thing first that I need you guys to pay attention on is what is the question saying. The question says calculate the magnitude of F, and F is a what? It's a force that is horizontal to the surface. So you need to draw the free body diagram indicating all the horizontal forces, which is your Fk going up, and then your force that they want us to calculate going up, then we have the Fg parallel going down. So now we're going to say F net is equals to Ma. Right, so I need you to remember that they said this moves at a constant speed. The acceleration is 0, so therefore your F net is just 0. Then we take direction. I'm going to choose up as positive, meaning that all the forces that are going up, then we subtract all the forces that are, oh no, I won't take up as positive because I forgot that this object is moving down. So I'm going to take down as positive. The direction of the motion as positive, it's always the best. So let's take down as positive. So all the forces that are going down, which is Fg parallel, we minus all the forces that are going up, equate this to 0. So now I think since you are preparing for final examination, you already know that FG parallel is equals to mg, the sine of theta, and FG perpendicular is equals to mg, the cos of theta. Right. So the FG parallel, where there's FG parallel, we're going to substitute. So I think, I'm not sure if we're going to have enough space to work this thing. I don't know. But let's try to keep going. So we're going to say this is FG parallel. We just said this is what. Let's quickly change the marker so that we don't make a mess. So FG parallel is mg. The sine of theta, we minus fk minus f, this is equal to 0. So if you understand where is this question, where is this equation coming from, we're just gonna move it down there. We're just gonna move this equation down and solve for that, what they are asking us to do. So let's rewrite that equation. We said we're going to have mg, the sine of theta is equals to, okay, I'm just gonna name this as 2.3. 2.3 it's mg, the sine of theta minus fk minus f is equal to 0. So now I need to do my substitution. What is the mass? They said this is a 25 kg crate, so the mass will be 25 multiplied by g, which is 9.8, the sine of that angle, which is the sine of 30 degrees, minus the frictional force, which was given as 40 newtons. So I'm going to substitute that as 40. So we're going to subtract 40 minus f, this is 0. Right. So remember that is equated to 0, and I'm very sorry about that mess. Né? Please forgive me. So now this will be equals to, I have f to be equals to, so I'm just going to move the f to the other side to be positive. This is 25 into 9.8 sine 30 minus 40. You punch that on the calculator, you'll have your f as what? Let's quickly put that on the calculator. So what is the value of f? That's 25 times 9.8. 25, 9.8, the sine of 30 minus 40. So I get my f as 82.5. 82.5 newtons, and it's going up. That is my force. So just in case the next question wants us to use this question, I'm just gonna highlight it for now. Né? Right, and that's it for this question. Let's see what we have on the next question. Oh, that was 2.3. Now they say when the crate reaches point A, now this crate is at point A. We can see from the diagram, you see now the crate is at point A, F is removed. They removed that applied force. So we no longer need this. And the angle of inclination is decreased to theta. Look at the angle is decreased to theta from 30. They change the angle to theta, so that the only thing that you need to understand is that the angle decreased immediately, so that the crate continue moving at 2 meters per second towards point B. So now the crate is moving to point B. Okay, use the relationships. Hey, you see now relationships. Some of you guys, I know that you are in relationships. So now when I say relationship and you look at the lesson, there's still 5 hours. And now you have a relationship that you need to attend. Hey, don't stand up, ne? Please sit down. Let's finish this lesson. Forget about that relationship. So when I look at this, I'm going to say the relationship between the forces acting on the crate between the points. Oh, they want us to use the relationship between the forces acting on the crate between A and B to show that UK is equal to sine theta all over cos theta. Alright guys, I'm going to have a problem with this one because I don't know what they want me to do. But look at how I'm going to analyze the question. First thing first, they said UK, the coefficient of kinetic friction. Where do we get that coefficient of kinetic friction? Where is that guy coming from? So I know that the UK comes from the formula that says frictional force is equals to the kinetic friction times the normal force. Okay, so if it's like this, how do I bring theta on this equation? Let's think about it. Ne? Let's think about this. What is the normal force equals to? Because this is uninclined. So remember, if this is uninclined, when we draw the free body diagram, the normal force acts up, and then the force that is opposite to the normal force, that will be Fg perpendicular. Then let's go back up. Remember we said what is Fg perpendicular equals to? It's mg the cos theta. Okay, now I have the cos theta. I can celebrate because I can see that I'm going somewhere. Ne? So I'm just gonna write this properly. Then we'll try to explain that again. We'll try to explain that again. We said Fk is equals to UK times the normal force. And we're saying that the normal force, look at this, the normal force on incline is equals to the Fg perpendicular. I think you understand why, because these are horizontal, these are vertical forces. So we're going to say up as positive, then we take the normal force, we subtract the force that is going down, which is Fg perpendicular, equate that to 0. So what do you get when you solve for normal force? Can you see that the Fg goes to the other side to be positive, which gives us Fg perpendicular. Normal force is Fg perpendicular. So where there's normal force, we can substitute. We set Fg perpendicular, it's mg the cos of theta. So where there's normal force, we can substitute this as mg the cos theta. So now look at this. I have the cos theta, and now I have the UK. How do I bring the sine theta into the equation? How do we bring that? I know that the only way in physics, especially in Newton's law, where we can get the sine theta is from this formula, the Fg parallel. What is that has to do with this? So I'm going to go back and say, no man, the Fk is a horizontal force. So if the Fk is a frictional force and it is going up, how can I work on that? So I know that if I draw the free body diagram indicating the forces that are acting on the crate, this is moving down, the Fk is moving up. This will be my Fk, and another force that acts on that is what? Fg parallel. Oh, now this makes sense. Remember, using Newton's law, this is equal to 0. So I'm just going to work on this now and say for 2.4, I can say that F net is equal to 0 because they said this moves what? At a constant velocity. So now I said we take down to be positive. And if we take down to be positive, we're going to say that all the forces that are going down minus, look at this, I'm looking at that free body diagram, minus all the forces that are going up. So now I know that I need to bring the Fk and what? And the Fg parallel. Why? Because the Fg parallel is the one that will bring us that sine theta. We need to put this in one equation, and the only way to do that is to use Fg parallel minus Fk, like F net is equal to 0, equate this to 0. Therefore, my Fg parallel is equal to the Fk goes to the other side. Let's substitute. What is your Fg parallel? So Fg parallel is mg the sine of theta. So this will be mg the sine theta, equate this to Fk. So now on Fk, we know that the normal force it's mg the cos of theta. So my fk will be equal to the coefficient of kinetic times mg the cos theta. So I have to substitute that. Where there's k, we need to put this as the coefficient of mg times the cos of theta. So what is next? The next thing is to solve for the UK. We can divide this side by mg, the cos theta, divide that side by mg, the cos theta. So now what happens when you divide both sides? These two guys, the mg cos theta cancels. This side, the mg and the mg cancels. Therefore, we've managed to show that the UK is just the sine theta over the cos theta. I'm sorry guys about the space now, but I think if I can give you the notes like this and send you this PDF, that's when you're going to be like confused, that's when you're going to be confused. But since you work with me step by step, then you understand why we have 2.3 there, why we have 2.4, why fk equals. So I think everything makes sense. So we've managed to do that. We've proved that uk is equal to sine theta over cos theta. So on 2.5, oh nice, this is the last question. 2.5, the coefficient of kinetic friction between the plate and the inclined. So we are given the coefficient of kinetic friction as 0.19. So they are saying that UK is equals to 0.19. Using the identity that sine theta over cos is tan, calculate the frictional force as the crate slides from point A to B. So you know what I'm going to do? Let me avoid the identity for now and try to understand what is the question saying. The question says calculate the frictional force. So now you're going to write the formula for frictional force. Which formula is for frictional force? That formula. You write it down and say, I know that Fk is equals to mg. Oh, it's UK times mg the cos of theta. This is our Fk, if you still remember. So on that Fk, we're saying Fk is equals to the coefficient of kinetic friction, then mg the cos of theta. So definitely this will be 2.5. So now we can see that we have the UK, which is given as 0.19, and then the mass of the crate is 25, and this is 9.8. So the cos of theta, this tells you that to find Fk, you need to first calculate theta. So that's why they gave us that identity. Then I'll go back and say they said sine theta over cos theta, I can write it as tan theta. But we know that sine theta over cos theta is what? Remember this, it's sine theta over the cos of theta, and it's equal to 0.19. We just proved that part. And then they said we can say sine theta over cos theta is equal to the tan of theta, it's equal to 0.19. You know, if I was the one setting this question paper, you know what I was gonna do? I was gonna say hence, and I was not going to remind you that part, that the identity, just to check if you know the identities from maths. So I was not gonna tell you, and then maybe I can say this is 4 marks if I was the one doing the question paper. Unfortunately, that's not me setting the question paper, so it's much easier, right? So now when it's like this, I can find my angle theta using the tan inverse. So we can say that theta is equal to the tan inverse of what? That 0.19. So when you punch that on the calculator, what is theta? Let me quickly do this. The tan inverse of 0.19, that's 10.76. 10.76 degrees. So now that I have this, I'm just going to substitute it here on cos theta, which is 10.76. So when you punch this whole thing on the calculator, we should get our FK, the kinetic friction, the answer for 2.5. So I'm just going to put it on my calculator. This is 0.19 times 25 multiplied by the cos 10 times 76. And this gives me 47.32 if 45.73 if we round it off. 45.73 newtons. And that's it for this lesson. I'm very happy that this wasn't easy. Imagine if they just give me to write this question paper. It's easy, and I pray that even the question paper for this year becomes like this easy. Né? So the reason most of the time some of the questions are easy are difficult, or you make mistakes, you guys panic in an exam. Don't panic because your brain won't function well. Okay, let's see what we have on question 3. Okay, so now let's continue on question 3. So on question 3, they say that a ball is dropped from point A and reaches point B in h meters below point A. So in a what? In time t. So the time from this point to that point, we have the time as t. That is t. So they say that the ball takes 2 seconds. So the ball takes 2 seconds to fall from B to point C. So from this one to this, the time takes 2 seconds. So that is delta t, 2 seconds. And then the distance from point B to point C. From point B to point C is given as 8 meters. See the diagram below. Ignore the effects of air friction. Define the term free fall. Free fall is a motion under the influence of gravity force only. Okay, the motion under. The reason I'm also writing this definition is that, remember we said we're going to answer all the questions on this paper. So it's a motion under the influence of gravity of gravity. Let's say gravitational instead. Gravitational force only. Then you'll get your 2 marks. So the next question, show by means of calculation that the time t is equals to 1 second, and this is just for 2 marks. I think we can try to analyze the question. Maybe we'll be able to answer this one the easy way. Né? So now what I'm going to do, I'll look at the set by means of calculation, show that the time t is equal to 1 second. What is time t? The time t is the time the ball traveled from A to point B. We need the time it traveled from A to B. So the time it traveled from A to B, we need to know the information that is given on that path taken. Okay, so now if we manage to analyze the question correctly and know our data, then it's going to be a ding ding ding, right? So now if we work on this one, let's see what we have on this one. I'm going to say that from A to B, what do we know so far about from point A to B? First thing first, we know that here it starts at rest because they said it is dropped. So it starts with an initial velocity of 0 meters per second. That's what we know. And then we know that from A to B, the acceleration A is equals to 9.8. Let's choose the direction. I'm going to take down as positive. The reason I say let's choose the direction is because I need to understand if my acceleration will be positive or negative. So since it's down, acceleration always acts down. So this will be 9.8 meters per second squared. That's my acceleration. And now we are looking for what? For t. So I'm just gonna say we are looking for delta t question mark. So which formula can we use? Because we know that delta y, the distance traveled from A to B, it is given as h. Let's first use this information, then we'll take it from there and see what we get. So now we need to choose a formula that doesn't have a v final. So if we go to the formula sheet, I'm very sorry that we need to scroll all the way down, but trust me, this is for the best. I need you to understand. Okay, so let's look for the formula that doesn't have v final. This one, it has v final out, v final, that one won't work. And then let's go this side. Do we have a v final? No. This is delta y. This is the formula that we can use. Delta y is equal to v initial delta t plus 1 over 2a delta t squared. So we have the formula. Let's go back up and see what we can do about that formula. Okay, so now on this one, we're going to say delta y is equals to v initial delta t plus a half a delta t squared. So do the substitution. Delta y from A to B is given as h. Remember, delta y is h, so I'm just going to say this is h. It's equals to v initial is 0, which will make all this to be 0. So I'm just going to substitute that as 0, because anything multiplied by 0 is 0. Then we add 1 over 2 into 9.8. Then what is delta t? The time from A to B, delta t is given as t. So the time is t. So this tells you that you need to substitute that to be t squared. So let's quickly work on h. What is h equals to? H is equals to 1 over 2 times 9.8, which is 4.9. So this will be 4.9 t squared. Guys, how can this help us? Because I'm trying to understand how can this information help us. We need to prove that t is 1 second. So let me think. Just give me a second to think about this. But let's do it together. By means of calculation, show that the time is equals to 1 second. Okay. And now I know that if this is point A and this is point C, we can find the time it takes for the ball to travel that. So if this is t and this side is 2 seconds, what will be the time? So this tells us that t from A to C, the time will be t plus 2. Then we can use that to find what? We can use that to find delta t. So what I'm trying to say is that let's calculate the distance traveled by that ball from A to C. Then we're going to use the same formula that says delta y is equals to v initial delta t plus half of a delta t squared. Let's substitute. What is the height? Please pay attention. From A to C is going to be h plus 8h, which is 9h. Equate this to v initial. It start at 0, which will make everything to be 0. This thing is 0. I'm not going to waste time on that. Then plus 1 over 2. The acceleration is 9.8. Now, delta t from A to C. We said that the time it will travel from A to C, delta t will be that t plus the 2 seconds. So where there's t, we need to substitute what? T plus 2, and this is squared. I'm sorry, let me quickly rewrite this equation, right? Because I don't want you guys to get lost. I don't think we are having so much fun yet on the vertical projectile motion. Hopefully on the upcoming questions we're going to enjoy them. So this is, we said this is h. Okay, we said that delta, this will be h, it's equals to, this gives us 0 plus 1 over 2, where this a we put 9.8 and t we said is t plus 2. T plus 2 is coming from the time it takes to move from A to C. Then now if we work this thing out, now remember we said the time from A to C, it's h plus 8a, so this will be 9h. So I'm going to have this as 9h, it's equals to, if I work this thing out, half of 9.8, it's 4.9. So this will be 4.9 into t plus 2 squared. So now if you still remember this t here, you see this t on this equation is the t that we are looking for, because where did we get that t? We got it from the time it took to travel this, which is t. We added with the time it took to travel that part, which is 2. So this t that we substituted is the one that we are looking for. But we have a problem, a very big problem. What is our problem? That part. We don't need the h. We need to get rid of that h so that we can be able to isolate t. So I think we can call this equation 1 and we can call this equation 2. So now when I look at equation 1, I know that h is 4.9 t squared, and the t, even this t, you see this t here is the time it takes to travel, so from A to B. So this tells you that the t is the same, is what we are looking for. So if we can substitute that, where there's h, let's put the 4.9 t squared. So I'm going to substitute this, and when we substitute, what do we get? We're going to have this as 9. Where there's h, I'm going to put the 4.9 t squared and equate this to 4.9 into t plus 2 squared. So now I know that since I have something like this, I can divide both sides by 4.9, because I see an opportunity that the 4.9 cancels and I'll be left with 9 times t squared, which is 9 t squared. Equate this to, I'm only left with what? This side, I'm only left with t plus 2 squared. Come on, do your algebra. Remove the square, square both sides. The square root of 9 is 3, and then let me quickly write this down. Let's go back to maths just for a moment. Remember, if I have 9t squared, which is squared, this will be root 9 multiplied by the root of t squared. Root 9 is 3, and then the square root cancel, we are left with t. So this will be 3t. So I'm just going to substitute that as 3t. So now let's put this. This will be 3t. It's equals to, the square root cancels. I'm left with t plus 2. So let's bring the t to the other side so that we can have 3t minus t is equal to 2. Then this will give me 2t is equal to 2. Oh, nice. Look at this. When we divide both sides by 2, what is the value of t? Therefore, t is 1 second. Then it's a ding ding ding. Therefore, remember we said 2t is equal to 2. Divide both sides by 2. What is t? T is equals to 1. Then it's a ding ding ding. We've managed to prove that the equation for that time t is equal to 1 second. Okay, so on this next lesson question, they say using equations of motion only, calculate the speed which the ball reach point C. So now we have a lot of information there, but maybe we can just try to erase this part so that you can understand what is going on here. They said they want us to find the equation of motions. Using the equation of motions, we need to calculate the speed with which the ball reach point C. So we need the speed that it will hit the ground with, and I'm going to say V initial there, it start with 0 meters per second. And then what do we know? We also know that A, since it's traveling, it's going down 9.8 meters per second, because we set down as positive. And then remember, we know the time it will take to reach point C. Let's talk about the time. We calculated this t to be, we proved that this t is 1, and we know that this is 1 second, and to travel from B to C, that's 2 seconds. So when we add those two, it's 3 seconds. So the time it will take to reach point C is 3 seconds. So we're going to look for V final. So we need to use the equation of motion that we don't have there. We're going to choose the equation of motion that we don't have delta Y. So let's go and choose the formula that we're going to work on. So we need to choose the formula that doesn't have delta Y. So if I quickly go down there on the formula sheet, and then let me see what I have. This one, I can use this equation because this one doesn't have delta Y. This one won't work. This one won't work because of that delta Y. So now let's say V final is equal to V initial plus A delta T. Then we can just do the substitution and work on this step by step. Okay. So now let's see what I have so far. This is V final. The formula is Vf. It's equals to V initial plus A delta T. Just substitute what we have. We are looking for V final. Initial is 0. We added this to 9.8 times the time that it will take to reach C, which is 3 seconds. Therefore, what is your Vf? You just say 9 times 8 times 3, and this gives us 9 times 8 times 3. This will give us 29.4 meters per second. 29.4 meters per second. And that's it for this question. Right, so let's look at what they need on the next question, what they want us to find. So determine the height for 2 marks from which the ball was dropped. The height from which the ball was dropped. So what I'm going to do here, they want us to find the height from A to C. Okay, they want us to find the height from A to C. But look at this. We know that the height from A to B is H, and the height from B to C is 8H, which gives us the height from A to C to be 9H if we add those two. So I'm just going to say my delta, the height from A to C, to answer this 3.4.1, the height from A to C, we know that it's 9H. So now the aim is to find H. How can we find H here? How can we find the value of H? Okay, it's fine. You know what I'm going to do? To answer this question? I'm going to say, remember this data. This data here is the data that we used to find V final, but we know that this data is from A to C. So since it's from A to C, we can also use that data to find delta what? To find delta Y from A to C. So this will be delta Y is equal to V initial delta T plus 1 over 2A delta t squared. So let's use this information. So delta y from A to C will be equals to V initial. But now look at this. Look at this. You know what I'm going to do? Remember, the aim is to find h. So I don't think this will work. I don't think this will work because the aim is to find h. Let's go back and look at h. H is the distance from A to B. So the information that we need to use from A to B is that one. So we know delta y, it's h. So where does delta y? I can substitute h. It's equal to v initial, it was 0, which will make all this to be 0, plus 1 over 2. We know that acceleration is 9.8. Then the time the ball took to travel from A to B, because we are looking for this h. So we're going to consider from A to B. The time we set it's 1 second. So I'm just going to substitute that as 1. And this is squared. So this is for 3.4.1. So now, therefore, when we punch that on the calculator, what do you get as your h? Your h will be half of 9.8, which is 4.9. 4.9. So my height h, it's 4.9. But now, what is the question saying? 4.9 meter. What is the question saying? The one, the ball from which the ball was dropped. Now we know what is h, and now we said 9h is the height from A to C. So we can substitute that and say this will be 9, which is multiplied by 4.9. So when you punch that on the calculator, you get the height that it travels. So maybe we can just put this here and say this is 9h, which is we can say that this is 9h, which is the distance from what? From A to C. And then we know what is h. We can substitute h and say this is 9. Where does h? We put 4.9. Right? So when you punch that on the calculator, what do you get? We get this will be 9 times 4.9, which is 44.1 meter. So this is the height the ball traveled from A to C. I hope you are happy with that. But now they say determine the height from what? The height of the ball at point B. What's going on here? The height of the ball at point B. Is this not what we... Oh, let's go. What is point B? So the height at this point. So this is easy, man. 8h. We know that from this point, the height is h is the difference there. It's what? The difference there is h8, and already we know what is h is 4.9. So we can, to find that, we can say that h, the delta y at point B, is equals to 8h, which is equal to 8 into 4.9. Then we multiply the two, then we can get the answer. Right, so when you multiply these two, let me quickly check this. So we are saying that we need to take the 8, multiply it with 4.9, and this gives us 8 multiplied by 4.9. What is this equals to? 39.2. So this is equals to 39.2. And that's it. This is 39.2 meter. I'm very sorry guys about the space, but I know that I make most of the questions easy, so I don't think you're going to be confused. So now let's talk about 3.5, which is the last question of this question 3. Okay, so far we are up 1 hour and 45 minutes. So sketch the position versus time graph of the motion of the ball from the moment the ball was dropped until it reached point C. So this was A, this was B, and this was C. So this is where the ball was dropped, then it moved downward. So let's draw the position time graph. Always remember that okay, the position will be on my y-intercept. So now this will be my position. in what? In meter. And this will be my time in seconds. So when I have this type of question, guys, I'm going to draw the graph and I'll definitely explain so that you can understand. So if you still remember, we said we take down as positive. So we have down as positive, and if this is down as positive, let's look at the height that our ball traveled. I'm going to explain this. So let's draw the two graphs for the positive and for the negative. Should we only do one that is positive? Okay, let's say we set it down as positive now. So down is positive, and then let's go back. Remember that the height, the maximum height is 44.1 meter. This is the height that will be traveling by the ball. And they said that on your graph, indicate the following. Take the ground as the 0 position. Remember, so at this edge 0 is the ground. Okay, take the position of the ball, or the position of the ball at which the ground was dropped. They want us to indicate the position, which is this one. It was dropped at 44.1 meter. So I'm going to write it down here and say this is negative 44.1. So I know that you are asking yourself, why am I putting it down here? I'm going to explain, don't worry. By the end of this, so just give me 1 minute, 2 minutes, then you'll understand the concept of graphs. So this is negative 44.1. So this is where my graph will start. Okay, so my graph will start here. So when it starts here, where is the graph going? The graph will start from this point, then it will move all the way down to 0, because we said we take down as positive. Okay, so now let's indicate some of the information on this graph. Let's indicate some of the information. So this is my graph, then it moves to that 0. So remember, we said that when we did our calculations, we said that it will take 3 seconds for the graph to reach the ground. So delta t here, this will be 3, and then now this 3 is from A to C. So now we need the time and the position of the ball when it was at point B. So what was the time at point B? If I still remember, it traveled this point with 1 second. So this tells us that somewhere here we can put 1, and then we can indicate that 1 second. And then when you indicate the 1 second on the graph, it's very important that let me redraw my graph and put it in the right shape. So the right shape, it's like putting it like this. Okay, let's try that again. Okay, there we go. So now this point here, it should be my 1 second. This is at point B. But now if it's at point B, what was the distance at that point B? Remember, we calculated this on 3.4.2 because we also need to indicate the distance. We said from point A to B, it traveled 1 second. And then what was the distance? 39.2. So this will be the negative 39.2. It's somewhere there. I hope you guys can see that. This is negative 39.2. That's that answer. So now when you have it like this, then you are done drawing the graph. But let's try to explain this so that this can make sense. Remember, we set it down. We take down as positive. So if we take down as positive, just know that the positive direction, it's down. So down as positive means that this is the positive direction. The positive direction, it's equals to downwards. Right. So anything above the ground, it's negative. Anything above the ground, it's negative. and we're going to say anything below, okay, anything above it's negative and anything below the ground will be positive. Okay, but now look at this, look at what is going on here. Point A is this point, which is the top. So I'm just gonna say this is my top, exactly. So now this top should have what? The top should have what we call a negative position. So the top should have a negative position. I know that someone will prefer to put no. The top should have a negative position. And then at point B, which is this one, this is point A, and this is point B. At point B, this should be, if this point is negative position, this one will be less what? This one will be less negative. Right, look at this. The more we go up, we reach the ground, and the ground is just point C, which is 0. So now we're going to say, if down is positive, the graph starts at negative. So it starts at negative. So this tells you that if we take up as positive, we were going to start here and say this is my 4.1, then the graph will move down to that point. So this one is for positive, then somewhere here we're going to have that 39.2. This one is if up is positive. Right, then this one will be, sorry, the graph is not accurate. I think you guys can see that because at 1 second we were supposed to connect this graph next, but let's just leave the positive because let's focus on making you to understand the one that we choose to be positive, which is down. Right, so now because the ball is falling in the positive direction, which is down, so that's why we start from negative 44, then it goes up. So the best way to cram this for you, you know what you have to do, buddy? If you want to get a ding ding ding, you know what you have to do? Just cram this and say that if I take down as positive and I want to draw the position versus time graph, for positive, that if I take down as positive, the graph starts at negative. Just know it like that. I think it's easy if we can just leave it like that. And that's it for this question. It's a ding ding ding. Then we go to what? We go to question 4. So let's see what we have on question 4.